We're beginning with the first section in chapter 6. This whole chapter is on probability, and I actually have a lot of fun with probability. I think it's a fun thing to learn. But the basics right here, it says the situation with several possible results is called an experiment. So that's the first thing you're going to write down. Okay? Okay, probabilities are a measure of how relatively often the results occur. Each result of the experiment is called an outcome. Outcome. The set of all possible outcomes of an experiment is called the sample space. For the experiment. And a sample space is always represented using lists. Lists. Okay, so here we have a 2 6-sided dice, one green, one red, and they called it dice in this case, are thrown and both numbers are recorded. List all the possible outcomes of the experiment. So notice they gave you a picture of every possible outcome here. Okay? But if you were actually to list it out, like in your homework, they're going to ask you for the sample space. You would actually write down, like say your first dice is X, and your second dice is Y.
You say 1, 1.
Yep.
1, 2,
Yep, it would be 1, 1. 1, 2.
I have a question. Can't we just do like the draw?
I'm just going to circle and draw an arrow.
We'll be doing something like that later. Okay? So, and then the end would be 6, 6. So, notice how I kind of did this. But if you didn't have a picture in front of you, you probably would want to write it out because you're going to need it to look at so that you can find your probabilities, okay?
Could you, in order to sort of shorten it up, for the X value, can you say 1 through 6, and the Y say 1 through 6?
Well, in a sense you could, but the problem is later on when you're listing different probabilities, you're going to want to look at the values.
Like what probability that will add to 5?
Yep, okay. So, part B says, how many outcomes are in this sample? Well, we have 6-sided dice times a 6-sided dice, which makes it 36 possibilities. Okay? So that's our first example of a sample space. On the next part, it says you have a small box containing 30 blue, 30 green, and 25 red paper clips. 2 paper clips are taken from the box and their colors are recorded. It says list all the possible outcomes for the experiment. Well, I know you can get a blue paper clip first, and then maybe a green. You could get a blue and a blue, and a blue red. Okay, what else could you get? You could get a green green, a green red. And then the last one would be red, red. So those are the two, these are all the possibilities you can get on this. Okay? All right, it says how many outcomes are in the sample space? 6. All right. An event is any subset of the sample space of an experiment.
So wait, Miss,
Yes.
to get the example 1B,
Yeah.
could you just have said like 2 paper clips times 3 colors equals 6? Is that like accurate for all of them, or is it just this one?
And this probably would have worked. Doesn't always necessarily. So, it says the definition of a probability of event. Let E be the event in a finite sample space, S. Let the number of E and the number of S be the numbers of the elements in E and S, respectively. in each outcome in S and if each outcome in S is equally likely, then the probability that E occurs is the probability of E, denoted like this. Okay, so in other words, you're going to take the number of possible outcomes in the event, number of E outcomes, over the number of outcomes in the sample space to find the probability of E happening. Okay? So I'll give you an example in a minute. Number of outcomes in the sample space. Okay? Real quick, say you have a dice. What are your possible outcomes if you roll a dice?
1, 2, 3, 4, 5, 6.
Okay, 1, 2, 3, 4, 5, and 6. Okay, so I want to know what is the probability of rolling an even? You have 1, 2, 3, right? So it'll be 3 over the total possible, so that's 6. And you could reduce that down to 1/2, right? So notice that the 3 is the possible E outcomes, and the bottom is the total outcomes.
Would you want us to keep it in 3 over 6?
3 was the number of evens in the rules. So I can get a 2, a 4, or 6.
Oh, you want to run 6 too?
Yeah. Yep.
I didn't really know what to do.
Okay? So that's a quick example.
If we were to get this problem on the test, would you want us to keep it at 3/6 or reduce?
You would probably reduce it. Okay, so let's keep going. Page over, turn the page. Okay, so when a sample space has n outcomes, all of which are equally likely, then the experiment is called fair, because you have an equal chance of anything coming out, right? Or unbiased. Okay? And each outcome has a probability of 1 over n, because that's based on the n outcomes. The outcomes are said to occur randomly. Okay, the opposite of this, have you guys ever heard of a loaded dice?
Yeah. Is that the one that's a cheater?
Yeah, it's a cheater dice. So basically it lands on one side because it's heavier on one side than the other. So it's more likely to land on that, okay? So then it wouldn't be so random in the way it landed, right? So that would be a biased or loaded dice, okay? Example number 2 says an experiment consists of tossing 2 fair coins and counting the number of heads. Consider the events of 1 head in all, 2 heads in all, or 0 heads in all. Are these events equally likely? So let's just talk about our possible outcomes. We could have a head and then a head, right? We could have a head and then a tail. We could have a tail, then a head, or we could have 2 tails. Those are our 4 possible outcomes in this case. Okay? Yes? You could write it in parentheses. That would be one outcome. This would be another. Well, parentheses are also used in writing up sets of data. And so in this case, we're thinking sets, okay? Sets of data. And Monet, you got caught on video for that. Okay. Okay, so it says consider the event of having 1 head total, okay? So that there's 2 possible events of having 1, okay? Of having 2 heads, you have 1 time of that, and having 2 tails, there's only 1 of those, okay? So what is most likely to happen? 1 of each, right? This one's the most likely to happen, okay? So, Are they all these events equally likely? No. Okay. Example 3A. A researcher is studying the number of boys and girls in families with 3 children. Assume that the birth of a boy or girl are equally likely. List the sample space. So we have 3 kids. Let's start.
A boy and a boy.
Boy, boy, boy.
Oh, 3 kids. Oh, 3
Mm-hmm. We
boy,
could.
girl, boy.
Okay, so we want to do boy, girl, boy.
Are you kidding me? You can have any number of children.
Okay, or we could have boy, boy, girl, right?
Oh my God, you can have all girl, girl, boy.
Or we could have girl, girl, boy,
Girl, boy, girl.
girl, boy, girl, 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 boy, boy.
Boy, boy, boy. What do you got that?
There's one missing. Which one are we missing?
Girl, boy, girl.
Girl.
Boy, girl, girl. Wait, no, Jake, girl. Yeah.
Girl, boy, boy.
Boy, girl, girl.
Okay, so these are all of our possible outcomes. Okay. So now it says find the probability that a family has 3 children. Of 3 children has exactly 1 boy. So where are our possibilities of 1 boy?
Girl, girl, boy, and girl, boy, girl.
Right here, right here, and right here. Okay? So we have 3 possible outcomes, and then out of 8 total. All right?
So there's no other way to find the sample space other than writing it out?
Not really. Well, you can use a tree. You can use one of those trees to find them all. I'll have to show you that in a little while. Okay, part 3B. It says, assume that the births of boys and girls are equally likely. Okay, so now we're going to look at 4 children now. Yes? Mm-hmm. So I have them all listed out. You guys bear with me, but I did list them all out. We have boy, 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 boy. Girl, boy, boy, boy. No, I'm not. So we have 16 sets.
Girl, boy, boy, girl on there twice. Don't you?
No, that's G, B, B, G there.
Girl, boy, boy, girl. And then on the top, girl, boy, boy, girl. Yeah, you have it twice.
1 and 2.
No, that's girl, boy. Oh my gosh, my
This is girl, girl, boy. I missed this one.
only have 15. Oh boy,
My mom.
All right.
Girl, boy, boy. What does it say? Girl, boy, girl, boy. I only have 15.
Did you want one?
With each birth, you only have a girl or a boy possibility, right?
4 times 6.
So 2 times 2 times 2 times 2 is 16. So I know that it has to be 16. Yep, 2 to the 4th.
I'm missing somebody.
Okay?
Where'd you get 2?
Because with each birth, you have only 2 possibilities, a girl or a boy.
Oh, so if you could have like a, there's like another gender, it would be 3 times 3.
Yeah.
Now name them.
Okay, so find the probability. Find the probability that a family of 4 children has 1 girl and 3 boys. Okay?
1 girl and 3 boys.
Yep, 1 girl, 3 boys. So here's one right here. 1,
And then the last 2.
2, 3, 4.
No. 5, no.
1 girl and 3 boys.
There's only 4 people.
That's it.
There's 4. It should be 4 out of 6. There's the ones at the end.
No, those are all girls. Okay, so it should be 4 out of 16. Okay? Or equal to 1 over 4. So the last thing you need to know is that in a sample space with any outcome E, the probability of one outcome should always be between 0 and 1. Okay? If I had an outcome of 1, what does that mean?
100%.
It's a 100% chance. If I have an outcome of 0, it's a Impossible chance, okay? So it should always be a fraction, a decimal of some kind, or 1 or 0, okay? So that is it for today in terms of my lecture.